What's up guys, MrMcLights here. Today we are going to be going over some exhaust fans and some things to check on your industrial building's exhaust fans. Let's get started. So as you can see, I have the belt off already. I opened up the exhaust fan. The exhaust fan's pretty easy to open up. You can see there's these little tabs on the side. You take the screws out. I like to leave one in, bend the cover over, but it's up to you. You can really do whatever you want. But you need to take the cover off. You can just take the top part off, but I also like to check my bearings and make sure that they're greased up. So, the first thing you're gonna do once you get your belt off is inspect your belt. See if it has any rips, tears, cuts. The belt you can just pop off with a screwdriver. You're also gonna look at the bearing itself. Does the bearing have any play? When you're pulling back and forth in this motion and that motion, this way and that way, does this piece have any play? Right now it does not feel like it has any play. And then lastly, you want to make sure that your bearings are greased. I like to really pack them with grease and give it a little spin, make sure it spins freely. After you're done doing that, you're going to come to your motor. Give your motor a spin, make sure it spins freely. You're going to want to listen to your motor. This is a 120 volt motor. It has a starting capacitor in it. Lots of times the starting capacitor is what goes bad. So, when you turn on the motor, you should hear a click, and that click is the starting winding coming off of the motor, allowing the motor to run at full speed. But in order for a 120 volt motor to get up to speed, it needs to have the capacitor give it a kick in the butt using the starting winding. Then there's a little switch, a centrifugal switch. As the motor starts up, you'll hear a click. That is the starting winding coming off of the motor to allow just the regular run windings to keep the motor running. In this particular motor, the starting capacitor was bad. Now, to get to the starting capacitor, you are going to remove this cover. Now you'll see I already replaced the starting capacitor in this motor, but I'm going to show you how you can test a starting capacitor. When you're using or playing with capacitors, you need to always make sure that you are being safe. These do hold quite a punch in them and they can hurt you. Capacitors can kill people if you are not safe around them. You always discharge the capacitor before you test it or use it. So as you can see, I have this one taped up because it's a little bit small for the cover, but if you look on here, you can see that it says 270 to 324 MFD. If you go ahead and get yourself a fluke meter that is able to test MFD, or really any meter that can test MFD, you want to have a range when it measures the capacitor of in between that 270 and 324. If you're getting like a 0.5 or a 0.0, that probably means your capacitor is bad and it's time to replace it. If the motor sounds like it wants to run and it spins like this, but it's not really starting up, and you give it a little spin and all of a sudden it kicks on, that's because your starting capacitor is bad. Your starting capacitor costs about $5 at Grainger, and it will save you $250 on having to buy a brand new motor if that's all that's wrong with your motor. Lots of times that is all that's wrong with the motor. Water will get in the starting capacitor, or it will just go bad after about 5 years, and then lots of people remove the whole motor and replace it, when you can probably get another 5 years out of this motor just by replacing the starting capacitor. So, that's MrMcLights' quick exhaust fan, helpful tips and tricks. Yeah, if you have any questions or if you want to see something in more detail that I left out, let me know. I'm going to close up this exhaust fan cover now, and I hope that you guys have a great day. Bye.